Welcome back, everybody. Today we're going to continue with Chapter 10 and our look at advanced algorithms. In this lesson, we're going to get into sort algorithms, as in ways to take a list of data and put it in order to sort it out. Now, there's literally hundreds of different ways you can do this, hundreds of different sort algorithms, each with their own advantages and disadvantages. Okay, something the top computer scientists on Earth are always working on is trying to find the next best sort algorithm, especially as our data sets get larger and larger. Okay, today we're going to look at a simple one called selection sort. So 10.2, we're talking about probably the simplest sort algorithm out there, selection sort. So the idea behind selection sort is to form a sorted list by repeatedly finding and selecting the smallest item in the list and putting it in its proper place. So we'd start by finding the smallest item in the list and putting it in the first index. Then we'd find the second smallest item, put in the second index, then the next smallest in the next index. So for example, if this is my list that I want to sort here, we'd start by locating the smallest item, which is a 1, and we would swap that with whatever's in the first index, as in the 9. So as you can see, first time through this algorithm, or first pass we could say, the 9 and the 1 swap. Then we do the same thing, we'd find the next smallest item. Now in this case that's the 2, which is already in the second index. We'll leave it where it's at. And then we'll go through, find the next smallest one. The next smallest was the 5, so we swap the 8 and the 5. The 8's already in the right spot. Okay, so we've effectively sorted our list using selection sort. So let's take a look at what the code for this sort looks like. So I have a method here called selection sort. Now typically your sort methods are void methods. They're not going to return anything. We just want it to sort that array, not necessarily give us an index or anything like that back. And I wrote this selection sort to work on an array list, okay, just because it could also work on an array and an array of any object or variable type. So we're going to pass that array in, and as we go through, we're going to sort that array out. Okay, selection sort starts with a loop that's going to run through not quite the entire array. We're going to run through index I equals 0 to the size of the array minus 1. The reason I don't need to go through the entire array is that once I know that the second to the last element is in the right spot, that means the last element has to be in the right spot anyways. And also with this, if I went through the entire array, notice here I'm looking at an I plus 1 on an inner loop. So if I went all the way to the I plus 1 where I was the last element, that would actually take me outside of the indexes of the array and give me an out of bounds error. Okay, so that's one detail with this. The outer loop is only going to run through everything but the last element. Okay, so we're going to run through the whole array, and for every index in the array, we're going to set the minimum value to the space at I. So we're going to assume the first thing we're looking at is the minimum. Then with the inner loop, we're going to set our j index equal to I plus 1, so in other words, 1 more than the minimum. Okay, because as I go through and I put things in order, I don't need to check that the beginning of the list is in order. We just need to take a look at everything that's left. And this will go all the way through the array, so all the way to the last element. We need to check if that's the smallest. And each time we go through, we're going to basically check and see if the next value is the smallest value. So if the array at .getI is less than the array at .getMinimum, so in other words, if the next element is less than the minimum, we'll reset the minimum's index to that j we're looking at. Okay, so this inner loop goes through the entire array and figures out which one's the smallest. Okay, the next piece of this is we're going to swap items if necessary. So if we found a new minimum and it's not the I we started out with from the beginning of that for loop, we're going to do a pretty typical swap algorithm here. We'll create a temp value with the minimum. Okay, we'll set the minimum to what was at I. We'll set what was at I to that temp value, and we'll just switch places in the array. And that would be the first time through the outer loop. What we'll do from there is go back. We'd say that I is then equal to 1. Okay, we now have the first element of that array in the right position. Now we'll find the smallest element in the rest of the list. Same thing, checking to see if we found the smallest. And then once we've gone through the entire thing and found the smallest, we'll swap if necessary, and then go through the rest of the list. All right, so let's take a look at how this code relates to that list we already sorted here. Okay, so again, we're going to start off on the outer loop with I equals 0. So in other words, we're going to take our first index, the 0th index, and we're going to go through the entire array. Okay, that's what the inner loop does. Looking for the smallest value, and if we find something that's smaller, we're going to swap it. Okay, so again, what that will look like here is we found the 1 was the smallest, so we're going to put the 1 in the first index and swap that with what was in the last index. Okay, that's one loop through my outer array, my outer loop here, one time through my outer loop. Then moving on, we'll have our index equals 1. So in other words, we're going to put the next smallest spot in the second index here. Okay, the inner loop's going to go through the rest of the array looking for the smallest number. And if it finds a smaller one, we're going to swap. In this case, no swap necessary. The 2's in the right place. And then so on and so forth. Okay, the third time through the outer loop, we will go to our third index, look through the array for the smallest number. In this case, that's the 5. And as I run out of room here, one more time through, okay, things are already in the right order. So we get the 4th pass through right there. Okay, that's how you can apply selection sort to an actual list. And that'll be something you need to do on the AP exam, is actually be able to run through it step by step. Okay, if you want to kind of click through these same steps here, I've got a link to these slides below where you can do that at your own pace. Okay, but that's how it works. Okay, and last thing we'll do is we'll talk about some of the advantages and disadvantages of selection sort as it compares to some other types of sorts. Okay, first advantage is it's pretty easy to program. It's going to be the simplest algorithm we look at. Okay, second advantage is the computer's really not doing anything very complicated with selection sort, so it has low memory CPU usage. Okay, so it's pretty easy on the computer. Major disadvantage is it is slow. It's basically the slowest way we can sort a list. And what I have down below here is a graph of the 3 different types of sort algorithms you need to know for the AP exam. Selection sort, insertion sort, which will be what we talk about in our next lesson, and then merge sort, which will be something we get to a little bit down the road. And it has a graph of how long it takes, okay, on average, to sort out a list with a number of items using, like we said, selection, insertion, and merge. Now, if we're doing lists of small items, okay, 1,000 items, 2,000, 300, 3,000, there really isn't a big difference. But as I start getting into 10,000 items, you can see a pretty significant difference here. And that's going to be a lot bigger as you get into large data sets with millions and billions of items in it. Okay, so moral of the story is selection sort, it's simple to use, easy to program. But if we're talking about large lists, it would not be the way to go. All right, so there you have it. There is selection sort. Like with our other algorithms, homework will deal with, can you step your way through this algorithm step at a time? Okay, can you see kind of how the pieces work? Can you make some variations on it? So give it a shot, and like usual, if you need help, if you get stuck, let me know. We're here to help you out.